Welcome to the Radar and Electronic Warfare channel. In this channel, you will be learning a lot of useful information about radar and electronic warfare systems. Stay with us and please click like and subscribe. In this episode, we will be discussing the first part about radar frequencies, and the radar frequency bands will be introduced. Before we present the characteristics and practical usability of each band, which we will do in our next video, we will define concepts such as target detection range, as well as angular accuracy and angular resolution. The frequency dependence on those parameters will be also discussed so that it can be understood, for instance, why the lower frequencies provide poor angular resolution and high frequencies shorter target detection ranges. According to the Institute of Electrical and Electronics Engineers, the frequencies within which radars operate are the following. In order to make the frequency bands easier to use, the IEEE has named these radar bands with letters, as displayed on the right of the table. Some special use radars do operate out of the L to Ka bands, as displayed in the next graph. In this graph, we can see the areas marked in green where radars operate, and we can also see another radar band designation system, that of NATO, which also uses letters to designate the bands. Stay with us as we further discuss some fundamental concepts of radar theory, such as target detection range, radar beam, angular accuracy, angular resolution. Radar detection range of a target is the maximum detection range of a target with a specific radar cross-section, RCS, for given values of detection probability, PD, and false alarm probability, PFA. The above-mentioned parameters, as well as the other parameters which affect the maximum detection range, will be examined and analyzed in our episode Pulse Radar Range Equation. It is very important to note that any maximum range value without the corresponding RCS, PD, PFA values mentioned above, as in the example at the bottom right, is meaningless. Radar beam is the main lobe of the antenna pattern, normally expressed by the angle, both horizontal and vertical, which indicates the direction at which the transmitted power is reduced by half. This angle is called 3 dB beam width. Angular accuracy is the target bearing and elevation accuracy of a radar. Angular resolution is the capability of a radar to distinguish targets close to each other in bearing and/or elevation. Some interesting facts we need to mention. Narrow beams provide better angular accuracy and resolution. The radar cannot discriminate the targets if their angular displacement is less than theta 3 dB. For a fixed antenna size, radar beams become narrower as the frequency increases. Next, we will discuss the atmospheric attenuation. The RF signal attenuation or reduction of the signal in the atmosphere is caused mainly by signal absorption caused by gases such as oxygen and humidity. The effect of signal absorption under 10 GHz is fairly low, as shown in the graph. It can be observed, however, that as the frequency increases, especially in the millimeter wave range, i.e. 30 to 300 GHz, the attenuation increases significantly, especially at certain frequencies. Notice the peaks in the graph. Next, two general rules are presented which help you understand the relation between specific frequency ranges and radar capabilities in terms of detection range and angular accuracy and angular resolution. As mentioned before, The atmospheric attenuation becomes higher as the frequency increases. Thus, relatively lower frequencies have to be used when longer range target detection is the main task of the radar. Rule 1. In general, lower frequencies provide greater target detection ranges. The angular accuracy and angular resolution of a radar are both related to the antenna size and wavelength ratio. In particular, for a specific antenna size, better angular accuracy and resolution is obtained when the frequency increases. For a specific frequency, the use of larger antennas provides better angular accuracy and resolution. Rule 2. In general, higher frequency values provide better angular accuracy and resolution. Conclusion: there is no perfect frequency band to provide both superior detection range and angular accuracy and resolution. Lower frequencies provide longer detection ranges, while higher frequency values provide better angular accuracy resolution. A compromise frequency has to be selected by the radar designer in order to obtain the required target detection range with an acceptable angular accuracy and resolution. The fact is that in many cases, platforms such as naval vessels have to be equipped with radars of different sizes and frequencies in order to obtain the overall operational requirements of target detection, resolution, and precision tracking. So, what are the basic technical parameters that have to be considered by a radar engineer in order to select the optimal frequency of a new radar system? Antenna size limitations, required detection tracking range, lowest acceptable angular accuracy and resolution. Thank you for watching. In our next video, we will continue with radar frequencies part 2. Please like and subscribe.